Very good afternoon, everyone. Very good afternoon. Welcome to today's Unit 1 class. Okay, we are all back after 1.5 weeks, right? And again, tomorrow we have another holiday, right? Okay, this practical exam that I'm trying to do with you all has been postponed again. Tomorrow we have a holiday. So guys, we'll put our practical exam for the week thereafter, okay? I was trying to have it for 2 weeks, but every 2 weeks, every time a holiday came up. Again, this week a holiday is coming up. So next week, Friday, will be your practical exam, okay? Right. Everybody, we'll continue in theory. In terms of a theory exam, there is a little more time. I'll tell you all when. Right, everybody, guys, girls, all of y'all, let's continue from where we stopped. Okay, we started topic 2, but we didn't do a lot in it. Okay, we did very little in it, and then we had our online quiz. So we couldn't do a lot. Right. So everybody, I'll have topic 2, right? Everybody, can I open up topic 2 with you all? Right. Guys, before we start continuing from where we stopped, any definitions for network? Topic 2 is entirely based on network now. Any definitions you can give me? I'll just show you an image over here. Look at this image and tell me anything that you can tell me over here. What makes a network a network? Sorry? You need to have minimum how many devices to create a network? You need minimum 2, right? You need minimum 2, and these devices have to be connected to each other. When it comes to connection, guys, what are your two options? What are your two mediums? You can be wired or it can be wireless, right? You can't simply connect devices and say it's a network. No, one more thing should be possible. How do you know the network is, how do you know the connection is successful? They need to be able to communicate. Excellent. Devices need to be able to communicate. Okay, when they can send and receive messages between each other, then you can say, you know what, network has been created. Then guys, I told you all, if you look over here, you can see devices are all connected to each other. Now the one with solid lines means they are using a wired connection. Those with these lines over here, there is no solid connection. It means their connection is wireless. Okay guys, and these devices, since they are connected in network, they can communicate with each other. I told you guys, when data travels in a network, it travels in the form of packets. Data travels in the form of packets. Okay, it's not one massive chunk of data traveling. Your data, let's say you're transferring a video, that video is broken into maybe a billion packets, and then those packets are sent to the recipient. Everybody okay with this? This is what we spoke about. We also spoke about one more thing. I told you any device that wants to connect to a network, it can even be a smartwatch, it can be a Bluetooth speaker, any device that wants to connect to a network must have a hardware component known as, I told you, without exception, any device connecting to a network must have this card with them. NIC, which stands for Network Interface Card. Okay, these are some of the basics. Any device that wants to connect to a network must have a network interface card. Every network interface card is given a serial number. In the factory itself, that number is given to them. What was that number called? Louder? MAC address. We were calling it MAC address. MAC is an acronym. What does it stand for? Media Access Control. We were calling it Media Access Control. Anything you can tell me about this address? It is unique. Every device has a unique MAC address. Anything else you can tell me? It uses hexadecimal. Excellent. It uses letters and numbers, which you call hexadecimal. Anything else you can tell me? It is unique. It uses hexadecimal. When you connect to a network, I remember I tried to show it to you all, but it didn't work. I switched on my laptop's hotspot. I told you all to connect, but none of you all were able to connect. I don't know what the reason was. I told you all, whenever you connect to a network, what gets recorded? Whenever you connect to a network, guys, your MAC address will automatically be recorded. You get it? So if I want to block you from my network, I block you by your MAC address. Are we all okay with this? Okay, right. So everybody, now let's have a look at our tute. Everybody, guys, girls, let's have a look at our tute. Where is it? 1 second, please. Let's move down. So everybody, we spoke about this network interface card. We spoke about the details of it. Okay. Then guys, now we need to move on to something called our hub. And I think we also spoke about hub, but I'll continue from there. Okay. Right. Everybody, we are looking at different components of a network right now. What are the components you all know of so far? You all know there has to be devices, a laptop, a smartphone, a tablet, a smartwatch, a Bluetooth speaker. There can be devices like this. You all also know that every device needs to have a network interface card, because if there is no network interface card, there is no way it can connect to a network. So far, so good. Everybody with me, right, on this? Right. Can you all come down to the next device now? Can everyone read with me? You all read and then I'll explain. In certain instances, I'll explain first and then you all read. So can everyone read a hub? Can everyone look at this gadget first? Look at this gadget over here below. This is what we call a hub. Network interface card we saw. This is what we call a hub. You can see there are various ports here where you can connect devices. So what does a hub do? Focus on the bold words. What does it say? Connect several devices in a local area network. Are you all okay with this? Let's stop there for a second. I haven't taught it to you all yet. But what do you all know about a local area network? I never taught it to you all, but what do you all know about it? From O level, any knowledge about local area network? Can I put the internet as an example of a LAN? Obviously no. Why did you say no? Wide area network. The internet is known as a wide area network. So what is a local area network? Very good. A local area network is a network that is limited to a specific location only. That network works only in a given location. If you take the internet, right? If you take the internet, guys, you can access the internet wherever you go. Okay, so the internet is not an example of LAN. LAN, local area network, are networks that can only be accessed in a given location. So for example, guys, think about your school computer lab. In your school computer lab, computers are all connected to each other. But you can't go home and access your school computer lab. You can't do that because your school computer lab is using what we call a local area network. Everyone okay with this? Can we put a small definition over there? Everyone over here, under LAN, I'm going to just draw an arrow and say a network that can be accessed in one location only. A network, I don't know, I can even read my handwriting. A network accessible in one location. This is what we call LAN, a network accessible in one location. Everybody okay with this? Then I want you all to draw a small diagram below also. We'll say, for example, guys, at home you have a router. Okay, we'll say at home you have a router. So I'll draw a dialog 4G router over here. You have a router at home. And this router, guys, you have your smartphone. You have your smartphone. I'll just say smartphone over here. You have your tab with you. Tablet, I'll say. You have your laptop also with you. Okay, I'll say laptop. Okay, you have these gadgets. All these gadgets are wirelessly connected to your router. Are all connected to your router through Wi-Fi. Through Wi-Fi, you have connected them all to the router. The router is not connected to the internet. Did you all hear what I told you all? The router is not connected to the internet. Okay, what type of a network do you have right now? Your devices are all connected to each other, but they are not connected to the internet. So from your laptop, you can access your tab. From your tab, you can access your smartphone. From your smartphone, you can access your laptop. They are all connected to each other, but they can only be accessed inside your house. Only inside your house you can access them. You can't go somewhere else and access these devices. So what do we call this network? This is what we call a local area network. So can you all put a circle over around it and say LAN? So now we put a circle over here and say LAN. This is what we call a LAN. The moment the router connects to dialog, the moment the router connects to Hutch, the moment the router connects to the internet, then that's not a LAN anymore. It becomes a WAN, a wide area network. Are we all okay with this? Okay, so now you all know what it is. Then guys, once that is done, read the second paragraph, everybody. Read the second paragraph below. A hub receives data packets and forwards them to all devices. Can we highlight that all? Because that makes a big difference to you. Okay? Forwards them to all devices. So all the data packets that come to a hub are sent to every single connected device. Okay? Then keep reading it. Only the intended destination device will accept the data sent. Only the devices that are expecting data packets or who are supposed to receive these data packets will take it. The others will just simply ignore those data packets. So guys, you all understand the function of a hub, right? A hub basically forwards everything it receives to everyone connected. Okay? It doesn't choose who to give the data to. Whatever it gets, it gives it to everybody. Are we good? Right, keep reading it. Okay, only the intended destination devices will accept the data. The other devices connected to the hub will just ignore it. Keep reading it. Each device is connected to a hub using a wired connection. This type of wired connection. Keep reading it, guys. It can be either you know what an Ethernet connection is, right? The network cable, I'll give you all details. We call it an RJ45 cable. RJ45 cable. Okay? It can be Ethernet or USB connection. There is a lot of unnecessary traffic in a network where hubs are used. You know why unnecessary traffic, no? Because the hub is forwarding data packets to all connected devices. Are all the devices taking these data packets? No. Some of them are saying, no, we don't want it. So there is some unnecessary data packets hanging around there, which can cause traffic. Okay? So this can cause a lot of data collisions. So everybody, boys, girls, where do you think we would use a hub? So everybody, I'll give you all a simple example. If you all take certain cricket grounds, guys, if you take the grandstand, every seat they provide a small TV. You get what I'm saying? Every seat a TV is given. If you take certain cricket stadiums, if you take the grandstand, the most expensive stand, okay, almost every seat they keep a TV for every seat. For every section there is a separate TV. All the TVs are showing the same content. Agree? All the TVs in the grandstand are showing the same content. Okay? So there is definitely going to be a server which is producing this content. Is it clear? You have various cameramen capturing various parts of the grounds. All that is captured and sent to a media room. In that media room, you have a producer who's putting all these clips together and then showing it on television. Is it clear? Then that content is being sent to all the TVs. So most probably they would be using what we call a hub over there. All those TVs in the grandstand would be connected to a hub, and that hub would be connected to a server. You get my point? Think about this. Think about the airport. When you go to the airport, guys, you have so many TVs in different locations telling you the flight schedules. What time is the flight going to land? What time it's going to depart? all the TVs are giving you the same information. So in the airport also, in a airport, since all the TVs are showing you the same information, most probably they would be using what we call a hub. All the TVs are connected to a hub. So there is one controlling computer that sends the information, and then all the TVs simply show it to you. Okay, agree with this? Right. Similarly, if you take a bank or if you take certain supermarkets, guys, all around the supermarkets, all the TVs are showing you the same content. So most probably all these TVs are connected to what we call a hub. Are we all okay with this? So this is what we call the function of a hub. A hub is used to forward data packets to all the connected devices. Okay, it's not a very complex device. There is no, you know what plug and play means? What does plug and play mean? Now this mouse is plug and play. Plug and play means what? Just connect it and start using it. No need to install, no need to configure, nothing. Just connect it and start using it. So a hub is also plug and play. You just connect the cables, you can start using it. There's nothing to configure, there's nothing, none of that will be done. There's no inserting of passwords and choosing of devices and none of that. You just connect the device, it will forward data packets. Okay? Everybody okay with this? Right. So I showed you all a picture of a hub also, right, guys, online? There was a message. What was the message about? Isam, give me a second. I'll do that. This is what we call a hub. Okay, you can connect multiple devices, but all the devices will be receiving the same data. Okay? Right. Now, before I go there, just think and see, in an office environment, do you think a hub is essential? Not really, no? In an office environment, it doesn't seem like we need a hub. Okay? So we'll see then what do we do in an office environment. Okay? Right, let's move down. Everybody, can you come down to switch? Everybody come down to a switch below. So Esan, all of y'all, can you collect this? So everybody, can you all read the first two paragraphs? A switch was developed as an improvement. Interesting. They are saying the switch is better than the hub. Let's see how. Okay. Due to the what was the inefficiency in the hub? Data collisions, because the hub is sending data to every device, whether they want it or not, it's sending it. And then devices have to manually say, you know what, these packets are not supposed to be, these packets are not for us. Okay, it's a lot of inefficiency was happening in the hub. This doesn't happen in a switch. So automatically, can we say data collisions are minimized? Can we say this? They told us improve inefficiency. So automatically you can say data collisions are minimized in a hub. Let's see how. Keep reading it. A switch is used to connect several devices in a local area network. So everyone look at this switch over here. You guys saw this? This is what we call a network switch. You have different sizes, 24 ports, 4 ports, 8 ports, 16 ports. You have different ports. Okay? All right. Stop there for a second. As the ports increase, what's going to increase? Inevitably, obviously. Not power. Power also. Bigger problem will be, as the number of ports increase, you're going to increase the number of devices connected to it now. So naturally, you have, imagine all the data is coming here and then being distributed from here. Can I say traffic is going to increase here? When traffic increases, collisions will also increase. Everybody okay with this? So it's nice to have lots of ports, but remember, connecting too many devices to one switch can also lead to lots of traffic. Okay? Right. Everybody, can you keep reading it? The major difference between a switch and a hub is that instead of transmitting data packets to all devices, what does a switch do? Read that to yourselves. Only sends data packets to the intended destination. Everybody okay with this? So switches are considered as smart devices. Do you know why? Hubs are known as dumb devices. Do you know why? Because a hub doesn't do any thinking. Whatever it gets, it gives. Everybody okay with this? A switch does some sort of processing. When it gets data packets, it checks where do I send this to? Which port do I give it to? And gives it to that port only. Are you all okay with this? Keep reading it, guys. It does this by using a device's media access control address. Now, guys, from where did this media access control come? What is this media access control? MAC address. Everybody, I forgot to touch on this. Last week, I gave you all the structure of data packets, right? Anyone remembers the structure? I told you, I didn't give you all the in-depth. I just told you all every data packet has 3 parts. There are more than that, but for now, I just gave you all 3 parts. What do you say? Didn't I give you all that? Boys, didn't I give you all a diagram? This diagram, I didn't show it to you all last week. I showed, didn't you all draw it? You all drew it also, right? I told you all every data packet has this structure. The header, the payload, and the trailer. Everyone okay with this? So everybody, header, payload, trailer, exactly. So in data packets, guys, inside the header, you will mention a lot of information. One of that information is the MAC address of the sender and MAC address of the receiver. Did you hear what I told you all? Inside this header, there is some more things which we'll be learning later on. Inside this payload, there is some more things which we'll be learning later on. Trail also has some more things. For now, I just gave you only 3. Inside this header, you have the sender's MAC address and the receiver's MAC address. Is it clear? So when data packets come to your switch, are you all with me, everyone? You're still drawing this? Okay, draw this below first. Data packet structure. Those who haven't taken it, take it down below. But remember, we are going to break this even further. Inside the header, sender's IP address, receiver's IP address, sender's IP MAC address, receiver's MAC address, all that will come. Right. So now, when a data packet comes to your switch, I told you the switch is a smart device, right? What does it do? It will inspect the MAC address. And then what does it do? It sends that data packet to that particular device only. Everybody okay with this? Does that make sense? Okay, right. Guys online, I'm making sense to you all, right? A hub doesn't do all this, but a switch does it. When data packets come, it reads the receiver's MAC address and then sends it to that specific port. You all know what port means, no? You all are nodding the head. Guys, these are ports. Every port, one device will be connected to every port. Agree? One device will be connected to every port. Okay, so the switch will read the receiver's MAC address and then send it to that relevant port. Okay. Boys, am I all of you okay with this? Right. Keep reading it, guys. Keep reading it, guys. A switch records all the MAC addresses of devices that are connected to it. Did you all understand that? It must do that, right? Why should it do that? Why should a switch record all the MAC addresses of the devices connected to it? To be able to send data packets to the correct destination, isn't it? Switches, guys, obviously they need to know the MAC addresses of every connected device. Then only it can send the data packets to the correct port. Sounds good? Right, boys behind, all of you all keep reading below. Can everyone stop here for a second? And stores them in a table. You all need to remember that, okay? We have something called a MAC addressing table. Okay, so what do we have inside this table? Inside this table, guys, typically we have port number, and then we have MAC address. Everybody okay with this? Inside a switch, students online, inside a switch, you have a table. A table is stored in the switcher's memory. In the switcher's memory, a table is stored. I'm going to ask you another question now. Inside the switcher's memory, there is a table. We call it the MAC addressing table. What does the MAC addressing table contain? The port number and the MAC address of the device that's connected to that port. Does that make sense? So here is my next question. What do you call that memory? The switch has a built-in memory containing the MAC address table. What would you call that memory? We spoke about this in topic 1. I'm not asking the type of memory. I'm asking what do we call that memory? It might be ROM. It might be flash memory. What do we call that? What did you say? Volatile. No. Volatile means it loses the data when there is no power. That is RAM. I'll give you all a hint. I told you all hardware devices have built-in instructions. No, driver is one of them. Firmware. Thank you so much. So this MAC address table is a part of the firmware. Under firmware, you have drivers, date and time, menu, settings. Now, MAC address table is an except. It comes only for a switch. It doesn't come for other devices. No, you get it. So this MAC address table will be a part of the switcher's firmware. Okay, right. Keep reading it, guys. Keep reading it. It looks at the data packet to find the destination MAC address and forwards the data packet onto this device only. This reduces the amount of traffic in the network and as a result, reduces the number of data collisions. This improves the performance of the network. Everyone okay with this? Now, guys, do you all know where to use a hub, where to use a switch? Okay. So if you have a scenario, if the examiner gives you a scenario saying this data must be displayed on multiple computers, you will say, you know what, go for a hub. If the examiner says data should be what you call independently sent to each device, okay, then you will say go for a switch. Okay, everyone okay with this? So you all know about network interface card, you all know about a hub, you all know about a switch. Let's make it a little more complicated. Next, what do we have? Next, we have a router. Now, guys, all of you all at home, I don't think have a hub. I don't think any of you have a switch also at home. Okay, but all of you have a router at home, isn't it? So what's so special about a router? Let's see. Can you guys read it? A router is used to forward data packets between devices in a network. Sounds very similar to a switch. So what's so special about it? Stop for a second and look at my screen. Guys, you all saw the switch? You all saw a router? A router has ports, agreed? It also has antennas. What could you say on that? Wireless and wired. So you can say immediately a router is supporting wireless connections as well as wired connections, while a switch is only supporting wired connections. Sounds good. Let's keep reading it. Keep reading it. It uses a special database called a routing table. Stop there. Switch was using. What was the table in a switch? MAC addressing table. In a router, a routing table. Keep reading it. To send data packets along the correct route to their intended destination. It does this by reading something called IP address, which we didn't learn yet. Keep reading it. Of the destination device that is stored in the data packet. Right. Everybody have your writing books with you all? Or if you all have space over here, even can you all note it down? Oh, take in your writing book, everybody take in your writing book. So everybody, boys, girls, can we do this once more? You have your phone with you? Last time you only couldn't connect to my laptop. You were not there last time, no? When you did the quiz, you were there? Theory quiz? Theory one not there. Okay, you have your phone with you? Can you try to connect to this? Boys, can everyone look at this? I want him to connect to my hotspot, okay? And I want to show you all what gets recorded. So I'm switching it on. It's called laptop ABCDEF123. Can you connect and see? ABCDEF123. Couldn't connect. Let me connect and see if I can. There, somebody connected. Who is this? iPhone. That's yours. Yours. Adil, you. Okay, everyone, look here. I want you all to say this. I can't zoom in. Guys, look here. 3 things got recorded. You guys saw? His device's name, his IP address, and his MAC address. Everyone saw it? Whatever network you connect to, these 3 things will be recorded. IP, your device name, which he can change. Agree? His device name, whenever he wants, he can change it. Is it clear? Is it possible for 3 users in this room to have the same device name? Very much possible. So device name is not really a strong thing because multiple users can have the same device name. Users can change their device name. Is it clear? So device name is not very strong. Then we have something called IP address. Every device that connects to a network is automatically assigned an address. We call that address IP. Now this is the thing. Boys, look here below. Your IP address is not permanent. Okay, later on I'll teach you how to make it permanent, but for now, IP address is not permanent. So when he disconnects and he reconnects, he might get a different IP address. Everybody okay with this? IP address is generally not permanent, it's temporary. However, his MAC address will always be this. As long as he uses that phone, every time he uses that phone, this will be his MAC address. Everybody okay with this? So now I want you all to look at that IP address. Whenever he connects to a network, he's assigned an IP address. Think of the IP address as his address of his device on this network. What did I tell you all? Think of IP address as a device's address on a network. Let's make it simple for all boys. If you were to send a package to me, if you were to send a parcel to me, what would you tell the courier person? When you send a parcel to me through Pick Me Flash, what do you tell the driver? What does the driver need to know? He needs to know my delivery address, right? And do you all agree? Every house in Sri Lanka has a unique delivery address. Every house in Sri Lanka or anywhere in the world has a unique delivery address. Just like that, guys, every device that connects to a network gets a unique IP address. But the thing that you all need to understand is your IP address is temporary. When you disconnect from the network, somebody else might get that IP address. Are you all okay with that? Just keep that in mind, okay? Your IP address is generally, you can also make it permanent. Normally, default, generally speaking, your IP address is temporary. Okay? It's given to you for some time. When you disconnect, it's taken and given to somebody else. Stop there for a moment. Why do you need IP addresses? Or why do you need an IP address? Why do you need an IP address, guys? What did I tell you? Your IP address is like your address on the network. So go on. It has to be done. I'm asking, why do you need an IP address? To connect to a network, as in so that data packets know how to get to you. You get it? If you don't have an address, the courier person doesn't know where to go. He doesn't know where to go and drop off your parcel. You get it? Just like that, if you don't have an IP address, data packets would not know how to get to you. You get it? So when you have an address, now data packets know how to get to you. Everyone okay with this? So when you connect to a network, guys, automatically your device name is recorded, but device name is never used. Device name is used for us humans to identify. Because for us, remembering a name is easier than an address, right? So we use device name. But the problem with device name is what? Can he put, for example, Aman's name and join the network? He can, right? He can easily do that. So it's not a very reliable method, but it's there. IP address is unique, but it might change later on. His MAC address is permanent. So if I want to block him from the network, what should I block? If I want to block him, block his MAC address. You block his MAC address, then he'll never be able to enter the network again. Are we good, boys? Okay. Right. Everyone, can you all read this now? Can you all take down this note, please? Everybody, whenever a device joins a network, 3 things are recorded: device name, IP address, and MAC address. Whenever a device joins a network, the following information will be recorded. Will be recorded. Device name, IP address, MAC address. Okay. Guys, take this down. Whenever a device joins a network, the following information will be recorded. Device name, IP address, and your MAC address. Are we good? Then everybody, guys, girls, everyone, can we come back to our note again? Can we come back to our tute again? If I'm going too fast, let me know. So everyone look here. Where is it? Where is the tute? Can you all read the second paragraph, everybody? Second paragraph, please. It uses a special database called a routing table to send data packets along the correct route to their intended destination. It does this by reading the IP address of the destination device that is stored in the data packet. Okay. It then sends the data packets towards the destination address and selects the most suitable route for it to take. Not confusing, bear with me. Now everybody, the switch was checking what part of the data packet? The switch was interested in what address? MAC address. Everyone okay with that? The switch was interested in MAC address. Router is interested in IP address. That's it. The router is interested in the IP address. So the router contains what table? A routing table. In that routing table, what do you think would be there? IP address of all the connected devices. The IP address of all the connected devices. So when data packets come to the router will read the IP address it should send it to, and then send it to that relevant device. Everybody okay with this? It will then send it to that particular device. Are we all okay with this? Sounds good so far? Right. I want to also tell you all one more thing. I'll tell that to you all a little later. I'll tell that to you a little later. Okay, right. So guys, we have seen network interface card, we have seen hub, we have seen switch, we have seen router. Okay, we have gone through all these devices, right? Can we come down to the next one, which we call modem? Everybody, can we come down to modem? Modem is short for modulator demodulator. What does it do? It converts analog signals into digital signals. Let's stop there for a second. Everybody, when you talk to your computer, everybody, can you look at me, boys, all of you all? Right now, I'm talking to my computer now. My computer understands what? Ones and zeros, agree? My computer only understands ones and zeros, which we call digital. When we say digital, we're talking about binary, one and zeros. Right now, what I'm talking, the sound of my voice is in analog form, which my computer doesn't understand. So there is a translator, or I have a sound card that converts my analog sound, that converts my sound into zeros and ones. Everybody okay with this? I have a sound card in my laptop that converts this voice into zeros and ones so that my computer can understand it. The same happens on the internet also. In Sri Lanka, what are the companies that you can connect to access the internet? What are the companies in Sri Lanka that you can connect to access the internet? You have Dialog, you have SLT, you have Mobitel, you have Hutch. All these companies are emitting data in analog form. Dialog is emitting data in analog form. Your laptop is not going to understand it. So you need a gadget called modem. What does the modem do? The modem will take these signals, convert them into digital form, and then give it to your laptop, then give it to your smartphone. Everybody okay with this? So guys, where is the modem kept in a network? Any idea? Where do we keep this modem in a network? Think about your house network. Where is the modem? The modem, guys, can you all read the last sentence? Modems are built into all modern devices that can be connected to the internet. So devices, your smartphone, your tab, all of them have a built-in modem. Also, one more thing, routers have a built-in modem. Do you understand that? Routers come with a built-in modem. Are we okay with this? Shall I just also note that down over there? Routers come with built-in modem, with a built-in modem. Routers contain a built-in modem. Contain a built-in modem. Routers contain a built-in modem. So guys, I want to do a small diagram now with you all. Can everyone come to your writing books now? Everybody come to your writing books below. So everybody, right, everyone, what I want to do is think of a school computer lab, okay? Think about a school, think about a computer lab. You have multiple desktop PCs, okay? So I'll just say computer lab over here, computer lab, computer lab. And inside this lab, guys, inside this lab, we have multiple PCs. Okay, so I'll just say PC1, PC2, PC3, PC4, PC5, PC7, and then we have PC8. I'm sorry. I want to connect all these devices to each other. I want them to be able to communicate with each other. What gadget would you tell me to use here? What gadget would you tell me to use here? A hub. I want them to be able to communicate with each other. I don't want everybody having the same message. That I don't have. So then you would tell me go for a network switch. So somewhere in the computer lab, outside the computer lab or inside the computer lab, we are going to have a network switch. Okay, so we have a network switch over here. It will look something like this. So many ports available. Okay, we call this our network switch. Okay, so now what's going to happen? Every PC is going to have a connection to this network switch. Agree with me? Every PC over here is going to have an Ethernet connection to this. Okay, so now you have, can you guys draw this? keep some space on the right. Okay, there's a few more things to come in. Okay, so now you can see devices can all communicate with each other. Can anybody access the internet at this point? Can anybody access the internet at this point? No, because nothing is connected to the internet, right? So now if I want to connect to the internet, what gadget would you tell me to bring in? You would tell me bring in a router. You would tell me if you want to connect to the internet, you need a router. So I'm going to draw a router over here. So now we have a router over here. And then what would you do, guys? What would you do? The computer lab still doesn't have access to the internet. How do you provide internet access for the computer lab? Boys, girls, the computer lab still does not have access to the internet. So what do you do then? Connect the switch to the router, right? Isn't it? Can you guys see? Look at the router, guys. Everyone, can you all see? A router supports wired connections. Can you all see? Up to 4. So you can take one Ethernet connection from the router and connect it to your switch. Okay? So now you can make one connection from here to here. From here to here, you have a connection. Right. Now everybody in the computer lab have access to the internet. Okay? Sounds good? All right. Correctly speaking, guys, we need to draw one more thing. We need to say internet service provider. It's connected to an ISP, internet service provider. Okay, and then through this, it's connected to the internet. ISP means internet service provider. I did not teach you all that, but you all know it now. Okay, internet service provider. Just a rough diagram. I don't need, beautiful drawings. Just for you all to understand where we use the switch, where we use the router. I just want you all to understand that. So guys, right now, boys, everybody, right now, what type of a network is the computer lab having? Right? Wide area network, isn't it? The router is working now. Right now, the computer lab is having a wide area network. Let's say I switch off the router. I switch off the router. What's going to happen now? It's going to turn into a LAN. Now you're going to have a local area network only. Everybody okay with this? We will say that there are staff members who have also connected to this router wirelessly through their smartphones. Okay. Through Wi-Fi, various phones have connected to the router. Okay. So here is my question to you all. So everybody, let's say, for example, the teacher has noticed students are completely misusing their access to the internet. Okay, we'll say, for example, teacher has noticed students are misusing their access to the internet. She wants them to be connected, but they should not be connected to the internet. What can she do? Remove the router, as in remove this particular cable, right? You will tell me unplug this, isn't it? She wants them to be connected to each other, but she doesn't want them accessing the internet. So all she needs to do is remove that particular cable. Okay. If the teacher doesn't want the students connected to each other, let's say it's exam time, she doesn't want them connected to each other, what should she do? Disconnect the switch, or you can say switch off the switch, isn't it? She can either disconnect the switch, okay? The moment she offs the switch, the moment she disconnects the switch, the moment she powers off the switch, then local area network in the computer lab is gone. Will it affect the smartphones? It doesn't affect the smartphones because the smartphones are wirelessly connected to the router. Everybody okay with this? Okay, so this is how you create a network. Now guys, I want you all to understand this. Can you all just imagine the amount of cabling that needs to be done in this lab? Your switch is at the end of the lab. You have computers across your lab. You have to take cables from your desktop all the way to your network switch. So you can just imagine the amount of cabling that needs to be done, right? A lot of cabling needs to be done. Sometimes, guys, I will show you later on, you will have computers on multiple floors and the switch is on the ground floor or maybe the top floor. Now you need to take cables across multiple floors. So then cabling becomes quite complex and it becomes very messy. Are we all okay with this? Right. Guys online, are we okay so far? Now, do you all understand the function of a switch and a router? What are the functions? A switch can connect what type of devices? Wired devices only. And it's a smart one. It can connect wired devices and send data packets only to a particular device by reading every data packet's MAC address. When it comes to routers, are routers also smart? Routers are also smart. What tables do they contain? Routing table. When they receive data packets, what do they look at? They look at the IP address. Okay, and they forward data packets to that particular device only. Okay. However, the router can support both wired and wireless. It has antennas now, so it can connect wirelessly also. It has ports, it can connect wired as well. Are we all okay with this? So now you all know about the router as well. Guys online, I hope it's making sense to you all. Okay, so now you all know about the router. Guys, the router is going to get a lot more functions. As we go along, I'll tell you all. Okay, for now you all know it forwards data packets, but there are a lot more functions that are about to come in. Okay, we'll see. Can we move on to the next one, boys, girls, everybody? Can everyone read the, where is it? This part. Right. Can everyone move down to gateway? What do you mean by a gateway? A gateway is used to connect one network to another network. Are we all okay with this? Is used to connect one LAN to another LAN or a LAN to a WAN. Everybody okay with this? You can connect two different networks using a gateway. Let's stop there for a second. In our previous example of the computer lab, who was behaving like the gateway? The router. Agree? In our example of the computer lab, the router was behaving like a gateway, right? Agree? Guys, agree? Up to the switch, what did we have? LAN. Isn't it? Up to the switch, we had a LAN. Devices are simply connected to each other. But through the router, this LAN was connected to the internet. Okay. So your router becomes the gateway here. Your router is connecting two different networks now. Okay. Right. Keep reading it, guys. One network will often use different protocols. What are protocols? Excellent. Can you put that word there? Set of rules. Each network has their own set of rules now. So when you're dealing with two different networks, the rules are different. Who is going to deal with these different rules? Your gateway will come into place. This means that when they are connected, they are not able to communicate effectively with each other. It's like they are speaking two different languages. Boys, all of y'all. A gateway acts as a translator between the two networks. converting data from one protocol to another to allow the networks to communicate with each other. Can I ask you all one more question, guys? When you're on Daraz, you're on Daraz's network now, you're doing all your shopping on Daraz, and then you go to checkout. In checkout, what do they ask you for? Your contact details, delivery address, name, things like that. Then they ask you, how are you going to pay? When you choose card, can Daraz handle your payment? Daraz is there only for the shopping part. For card, what do they do? Have you all seen the message that comes on the top? Pay here, gateway. Exactly. They'll say what? Redirecting you to your payment gateway. So then they'll send you to Sampath Bank payment gateway, HNB Bank payment gateway. You get it? So you're going from Daraz's network to another network. That gap is what we call your gateway. You get it? The way Daraz operates and the way Sampath Bank operate are two different things. Okay, so that gap taking you from this network to another network is what we call your gateway. Okay, so you do your shopping on Daraz, and then through Daraz, through a gateway, you are put on to Sampath Bank where you do your payment. And then again, you are brought back to Daraz to say order is confirmed. Everybody okay with this? So a gateway connects two different networks. Are we good? Shall we move down to the next part? Then guys, let's have a look at a bridge. A gateway connects two different networks now. What does a bridge do? A bridge connects two similar networks together. Everybody okay with this? Two similar networks are connected together using a bridge. Connects one LAN to another LAN. So where would you use a bridge? Everyone, where would we use a bridge? Can you guys read the next paragraph? Let's say, for example, think about a university here. A university is very big in size. It has so many departments across a large geographical area. Okay, within a building, there might be so many buildings next to each other. Each building, the university may have local area networks in different buildings and sites around the university grounds. The LANs may be too far apart to work effectively as one single network. So a bridge can be used to join each of the LAN networks to create a large local area network. Shall we draw a diagram for this to make it more sensible? Okay, so everybody, can you come to your this thing? We'll put the heading bridge. I'll give you all a simple example. Okay. So we'll take, for example, we'll take a building, not a building, we'll take a entire, this thing will look. So over here, for example, guys, room 1, room 2, room 3, room 4, room 5. So inside each room, guys, you have devices. So we'll say PC1, PC2, PC3, PC4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. Hmm. Okay. In each room, you have devices, multiple devices. Okay. Now, bringing all these devices into one switch, you can imagine the amount of traffic that's going to take place, isn't it? If you bring all these devices and connect them all to one switch, you're going to have a massive amount of traffic when these devices communicate. So what you do is you put a switch for every room. For every room, you build a switch. In every room, you put a switch. Now all your devices are connected to this switch. Okay. So now you have 5 local area networks here. And your objective is, I want all these devices to be able to communicate with each other. Room 3 devices should be able to communicate with room 2. Room 4 should be able to communicate with room 1. They should all be basically able to communicate with each other. Is it clear? So then what you can do is you can now connect these tiny LANs all together using a bridge. While you are writing, can you tell me what is the difference between a bridge and a what do you call gateway? A gateway can connect to different networks, LAN to WAN, but a bridge can only connect similar networks together. A bridge can only connect similar networks together. Okay. So now you can have a bridge. You can have a bridge now and bring them all together. Everybody okay with this? So a bridge is used to connect multiple similar networks together. Okay, so can I just put a simple note over here? Each room contains its own LAN. Each room contains its own LAN. All the LANs are connected to each other using the bridge. Okay. All the LANs are connected to each other using the bridge. Sorry, we'll take in about 5 minutes. Okay, what's wrong? Okay, shall we move on to the next part, guys? So we have gone through network interface card, hub, switch, router, bridge, gateway. Okay, we've gone through a lot of components of a network. Okay, can I move away from here? Okay, think about the bridge. Like for example, think about this, guys. In platinum, we have, boys, all of you look here. In platinum, guys, we have separate flows. Okay, we have separate floors. We could have put everybody on one floor, but you can imagine the mess, right? We could have put all the classes on one floor. It would have been a complete mess. We put them all on separate floors, but you are all connected to all the other floors also through the lift, right? Or through the staircase, you can say. We have a lift that allows us to connect with all the floors. Okay, the same concept you have as a bridge. They're all separate rooms, but through the bridge, all these rooms are now connected to each other. Okay, because if we kept all of them connected to one switch, we would, if we connected every device to one common switch, massive traffic. Is it clear? So it will be better we connect each room to one switch, and then those switches we connect to a bridge. Okay, right. Let's have a look at one more and then we'll take a break. So everybody, can we have a look at, can you read the last paragraph? A bridge works in a very similar way to a switch. It reads the MAC address. Okay, can we remember that, guys? A bridge reads the MAC address. Okay, and forwards the data packets to its correct destination. If the bridge sees that the MAC address for a device is another, if the bridge sees that the MAC address is for a device in another connected LAN network, it will forward the data packet across the bridge to that network. Then, guys, the next one, of course, is not very complex. It's what we call a repeater. Another word could be extender, booster. Can you all put down those two words as well? Repeater, sorry, extender, booster. So what does it do, guys? Like the name says, it simply extends the strength of your wireless signals. Not only wireless, it can even be used for a wired signal. Okay, sometimes, guys, at home, your room signals are poor. Everywhere around the house, it's okay. Since your room is in a corner or something, signal is quite poor. What can you do? You can use a booster or an extender or an amplifier or a repeater. What does it do? This gadget will collect the signals and then extend it, amplify it, strengthen it. Okay, guys. Okay, can you guys read it? A repeater is used to boost the strength of an electrical signal, meaning it can travel further across a network. Guys, wired now, wireless cables, every few feet you go back, you can notice a drop in signal now. Wired cables, guys, every 100 meters, there is a small drop in your connection. Every 100 meters. So if you have a cable running for what you call 10-20 kilometers, after a point, the signal quality is going to be very low for wired cables. Okay, so what do they do for wired connections? Every so many kilometers, they'll put a repeater. What does the repeater do? Collect the signals, strengthens them, and sends them again. Everybody okay with this? So like every 10 kilometers or 5 kilometers, in wired connections, they will use a repeater to strengthen the signals as it travels. Okay, guys, you all know underneath the oceans, you have cables running, right? Connecting the whole world. Do we know about this? Underneath the oceans, we have cables running, connecting the whole world together. So these cables definitely have repeaters every few kilometers to maintain the signal quality. Because after 5 kilometers or 10 kilometers in a wired connection, the signal will come zero. So you need to have repeaters to keep the strength. Keep reading it, guys. Electrical signals are transmitted around a network to send data, but shortly after an electrical signal is sent from a device in the network, it will start to get weaker due to many factors. Electromagnetic interference, physical obstacles. Okay. If the signals get too weak, it will not be able to reach its destination. Don't we all have this problem? We have all experienced this problem, right? You have connected to your Wi-Fi network, but it's connecting, but signals are just not reaching your device. Okay, it's too weak to reach your device. So what can you do in between? In between, you can use something called a repeater. A repeater can reconstruct an electrical signal that has become distorted due to being too weak. Are we all okay with this, boys behind, all of you all okay? So we have gone through a variety of network components. Okay, again and again, I'm repeating this list. Okay, what are the components we have gone through? Went through hub, switch, router, what? A modem, gateway, bridge, repeater. We have gone through a variety of devices. Okay, guys. We have server then. So can you come on to another one, which we call a server, guys? I think I didn't show you all this picture now. So we saw router. Guys, this is a diagram for a bridge. Okay, you can see you have a network over here, you have a network over here, and both these networks were connected together using a bridge. Okay, so now you have one big network. Okay, earlier it was one network here, one network here. Then guys, we have repeaters. Have you all seen gadgets like this? MI has one. What do they call it? MI Wi-Fi extender. Have you all seen? In Sri Lanka, it's available. You can connect. You all know what I'm talking about. MI Wi-Fi extender. MI Wi-Fi extender. Okay, so it's a gadget like this. You can control it from your smartphone as well. You just connect it to your power supply, and then to your phone you can choose what Wi-Fi to connect to, and then you can extend the range of that particular router's Wi-Fi signals. Okay, right. Then guys, we move on to servers. So servers are extremely powerful computers that can handle many users at the same time. So guys, normally what type of a computer is a server? Supercomputer, or you can say mainframe, right? Server computers are typically supercomputers or mainframe computers, and they can handle many users at the same time. So why would a network ever need a server? Why would a network need a server? Everyone? To store data, close. So guys, when you all connect to Instagram, are you connecting to a server? When you connect to Instagram, you're connecting to Instagram server. So what is Instagram giving you? What does Instagram give you? They provide you with what? Words are not coming. All of y'all, what do servers provide you with? Servers provide you with access to resources. Everyone okay with this? A server provides you with resources. So if you take Instagram, guys, they are providing you with a platform. On that platform, you're able to put out photographs. You're able to put out reels. You're able to have a status. Are you guys okay with this? You can communicate, you can comment on other people's stories. You can comment on people's posts. The resource that Instagram is sharing with you is a platform. Okay. So can you guys come down to servers? So it's an extremely powerful device. A server is a device that accepts and responds to requests that are made for different types of data that are stored on the server. Okay, so a common example of a server is a web server. So when you access ikman.lk, pizzahut.lk, instagram.com, when you access these websites, you're accessing a web server, a server computer that is responsible for sharing the website files with you. Are we all okay with this? Okay, keep reading it, guys. Keep reading it. A web server, what does a web server do? This type of server stores the web pages for a website and responds to requests for the web pages by sending the data for the web page to the requesting device. Okay. So guys, anyway, I haven't taught this to you all yet. What do you call a device that connects to a server? Client. So you guys are all clients. All of y'all, when you all connect to Uber or PickMe or Ikman, whatever the site is, your device is a client. It's getting data from the server. Are we okay? Keep reading it, guys. Servers are single board devices like a computer that has a single board called the motherboard. Servers are often stuck together in a rack. Can you guys say this? There's hardly any monitor as such. What do you think it contains inside it? What do you think all these stacks contain? Data, meaning, so these are all going to be hard disks, right? These are all a collection of hard disks. Okay, hard disks to store your data. Everybody okay with this? If you zoom into this, I can't zoom into this, but if you look carefully, you will see all hard disks are stored over here. Okay, it's a huge number of hard disks. That's why servers have such a large memory capacity. Are we all okay with this? So we have different types of servers. Where did I put that? I haven't mentioned it here, no? Okay. Everybody, can you all go through that? Okay, so another component of a network is a server. Not every network will have a server. Okay, certain networks will also contain a server if they have many users accessing that network. So if you take Gmail, if you take Instagram, you take Facebook, they will have servers. Okay. Then guys, we have another device called a wireless access point. Okay, can you all first read it? After we'll draw a diagram. Everybody read the wireless access point below. A wireless access point is a device that lets wireless devices like laptops and smartphones connect to a wired network using Wi-Fi. That's so confusing, right? Allows smartphones and laptops to connect to a wired network using Wi-Fi. Wi-Fi is wireless, right? Smartphones also connect wirelessly, right? How do they connect to a wired network? Pretty confusing, right? Let's see how this works. Okay. So everybody, guys, girls, all of y'all, what we're going to do now is we're going to draw a small diagram for wireless access point. Can everyone do this with me? Let's say wireless access point. Wireless access point. Okay, so I want you all to imagine a large house. Okay, a large house. We can do multiple floors, or we can just talk about a large house. So we'll talk about a large house, Velu. So we have a large area. Okay, we'll consider it as a stadium or whatever you call. Okay, and over here, guys, in this large area, we have our router. We have our router, and the router is connected to your ISP. Okay, the router is connected to your internet service provider. Now over here you have a bunch of devices, a collection of smart devices, laptops, smart TVs, smartphones, many devices over here. Okay, so we'll have a collection of devices over here. PC1, PC2, PC3, PC4, PC5, PC6. Okay, I want you all to imagine all sorts of wireless devices over here. Everyone, are you all drawing with me? Girls, all of you all drawing? Come on. Okay, imagine you have a huge number of wireless devices over here. Okay, now do you think this router will be able to cover this entire area? Answer is obviously no. This area, the router alone will not be able to cover. Okay, guys, even though in the diagram it looks small, I want you all to imagine real life, like in a massive space. Okay, a router alone will not be able to cover it up. Okay, so instead, guys, in between what can you do? In between, what you can do is you can have a gadget called a wireless access point. Okay, you can have, for example, somewhere over here you can have WAP1. Somewhere over here you can have WAP2. Somewhere over here you can have WAP3. Okay, everybody, you have put wireless access points around this large space. Now everybody, look here carefully. Each wireless access point will have a wired connection to your router. Understood? Boys, are all of you with me? Each wireless access point is having a wired connection to your router. Look at this. Wired connection to the router. Look at this. Wired connection to the router. Are we all okay with this? Each wireless access point has a wired connection to a router. Each PC, these PCs can be smartphones, smart TVs. No, smart TV doesn't connect wireless. No, think about phones, tablets, and laptops. Phone, tablets, and laptops. What do? They are all wirelessly connected through Wi-Fi. Wirelessly connected through Wi-Fi. Okay, wirelessly connected through Wi-Fi, and then maybe these two will be connected to this router wirelessly. Everybody, boys, stop and look here for a second. Everybody, how does PC1 access the internet? It sends a request to the wireless access point. Stop for a minute. The wireless access point and the router, how are they communicating? Smartphone and wireless access point are talking wirelessly. Okay, and they are close by to each other, not a problem. Wireless access point 3 and the router are quite far away from each other. How are they communicating? Wired connection. So what do you think about the signal quality here? Why no? Wired connection, no. Wireless access point is having a wired connection to the router. It will be for wired connection, distance doesn't really matter, right? And it's like 10 kilometers, 50 kilometers. We are assuming it's a large area, but not in 5-6 kilometer size. Okay, so it's a wired connection. Wired connections are generally much stronger than wireless. So what's going to happen? Can I say this? PC1 has wirelessly connected to a wired network through Wi-Fi. Can I say that? Everyone look here. PC1 has wirelessly connected to wireless access point 3. Wireless access point 3 is having a wired connection to the router, isn't it? So can I say this? PC1 is having a wireless connection to a wired network. I can say that, right? Does it match with the definition of wireless access point? The wireless access point makes it possible for wireless devices to have a wired connection to a network through Wi-Fi. Sounds very confusing, but if you just stop and think about it, you see the device wirelessly connects to the access point. The access point has a what? Has a wired connection to the router. Everybody okay with this? Can you all draw this? I'll give you all a good example for this. You all tell me, you all first draw this video. Guys online, are we okay with this? Every wireless access, every device here, smartphones, tablets, laptops, they are all wirelessly connected to the access points. They are all wirelessly connected. But every access point is having a wired connection to the router. So you can say a wireless access point allows wireless devices to connect to a wired network through Wi-Fi. One second, please. I'll ask you all a problem. You all tell me the solution for it. Think about a hotel with 3 floors. Okay. Or we'll make it simple, a hotel with 1 floor. And on that floor, they have 40 rooms, we'll say, we'll make it simple. A hotel with 1 floor, and there are 40 rooms. And on top of those rooms, you have the front office. Then you have the, what else you need? Housekeeping, laundry, all those departments also, they are in the same floor. The hotel provides Wi-Fi for all customers. Okay. Whether they are on the ground floor, first floor, rooftop, wherever they are, as long as they are within the hotel premises, they have access to Wi-Fi. All of you have been to hotels now? Okay, and hotels normally provide this. Speed might be a bit of a problem, but normally wherever you go into a hotel, you can connect to the Wi-Fi network. Now guys, wherever you go in the hotel, Do they tell you, sir, if you are going to that end of the hotel, this is the Wi-Fi password. If you are in this side of the hotel, this is the Wi-Fi password. Do they ever say anything like that? They give you one Wi-Fi password, they give you one Wi-Fi network, and you always connect to that, isn't it? Everyone, are you following with me? Now in Platinum, guys, when I come to this classroom, I have to connect to one router. When I go to the next classroom, I have to connect to another router. When I go upstairs, I have to connect to another router. Every classroom has a different router in Platinum. In hotels, guys, no matter which room you go to, no matter which floor you go to, all the guests connect to one router. Agree? Agree, right? When you check in, guys, they give you a piece of paper and say, sir, this is your Wi-Fi username and password. Agree now? Do they provide a separate router for every room? They don't. In the room, do you get a router? No. There is no router. So how do hotels manage this? And they normally give you unlimited access, right? They say Wi-Fi is a part of the deal. So how do hotels do this? Hotels, what do? They will have 4-5 routers. And all 4-5 routers will be connected to all these wireless access points. These wireless access points will be in various parts of the hotel. Ground floor, first floor, second floor, rooftop. You get it? Maybe some rooms will also have a wireless access point. Is it clear? And these access points will be connected to multiple routers. You get it? But on your phone, what do you see? You see only one network. On your phone, when you enable Wi-Fi, you only see one network and you connect to that one network. Now, as you're moving around the hotel, you don't realize, but you're being switched from one access point to another access point. You get it, guys? As you're walking around the hotel, you come to the ground floor, you go to the first floor, you go to the rooftop, you go to your room, you go to somebody else's room. As you're moving around the hotel, access points are being automatically changed, but you don't realize it. You get it? You have a seamless operation. For you, it's automatically happening in the background as you move around the hotel. How are they doing it? They are doing it using access points. Everybody, does that make sense? If you look at hotels, guys, many of the hotels, guys, you would notice on the roof, they would have a kind of a white color thing fixed on the roof with a blue and green color light blinking. That's the access point. Everyone okay with this? Okay, so let me just show you an image here if I have one. Yeah. Oh, I don't have that image. We call that a wireless access point. Where is it? We'll do some questions after this. Wireless access point. It's normally fixed on the ceiling, something like this. Those are routers now. Okay, everybody okay with this? Like this, a gadget will be fixed on the roof, no buttons, nothing. Okay, just you'll see LED indicators blinking. Okay, that means the connection is connected or whatever. So this is how hotels provide you with Wi-Fi. Okay, they don't give every room a different router. No, they have one connection only here. But you don't realize in the background you're being switched from Wi-Fi access point to Wi-Fi access point. Okay, right. I want to ask you one more thing, which is yes. Can you wirelessly connect to your router? Look at PC 7 and 8. PC 7 and 8 also connecting wirelessly to the router, right? So can I say this? Your router also behaves like a wireless access point. I can also say that, right? Everyone okay with that now? PC 7, guys online, are you following with me? PC 7 and PC 8 are connected directly to the router. So now you can say, look at this. The router is also behaving like a wireless access point. So guys, tell me the functions of the router. What are the functions of the router? Does the router connect to your ISP? Does the router connect to your internet service provider? Yes, sir. Your router only connects to dial-up, no? Your router only connects to SLT Mobitel, isn't it? So number one, router connects to your ISP. Your router forwards what? Data packets to the correct device. Function number two. Function number three, it has a built-in modem. It has a built-in modem to convert what? Analog signals to digital signals. Can the router act as a switch? Yes or no? Why are you thinking? Does it have ports? So then yes, right? It can act as a switch. Not as many as a network switch, but it can accommodate a few devices. So it acts as a switch. It has antennas, no? So it acts as a, it has antennas, which means wireless devices can also connect to it. So it acts as a, we spoke about it just now. It has antennas, it can wirelessly connect to devices, which we call wireless access point. It can also act like a wireless access point. That is 5 functions of your router. So your router is a major device for the network. It can do so many things. It can act as an access point. It can act as a modem. It forwards data packets. It can act as a switch. One more is there. It acts as a gateway. Number 6, connecting what and what? Up to your router, what do you have at home? You have a LAN, and then through your router, you are connecting to your ISP, which we call wide area network. So your router also acts as a gateway. 6 functions. Okay. What's the time? Guys, can you read these last 2 paragraphs? It is possible for some network components to be combined into a single device or built into other devices. We just spoke about this. The router is a mixture of many devices, isn't it? The router is a mixture of many devices. For example, if you think of the device that you call a router in your home or school, this is normally a combination of a modem, a router, a gateway, an access point. You can also mention switch. Okay. Sounds good. Can we do at least 2 or 3 past paper questions, guys, before we go away from here? Shall we have a look at topic 1, part 3? Or do we have anything over here? Okay, can we do question 1, everybody? The network uses a switch. Explain how a switch differs from a hub. Intended device, correct? Shall I start like this? Shall I say the switch is a smart device while a hub is a dumb device? A switch does processing, right? A hub just forwards everything it receives. We'll start with that, Willow. A switch is a smart device since it forwards data packets only to certain devices. It does this by reading the recipient's MAC address. It does this by reading the recipient's MAC address on every data packet. Okay. We can also go on to mention it contains a what do you call MAC address table that helps it identify which port to send the data packet. You can, but not necessary. Now talk about the hub. The hub is a dumb device since it forwards all the data it receives to all its connected devices, since it forwards all the data it receives to all its connected devices. Okay. From topic 1, part 3, can we do one question before you all go? From topic 1, part 3, just one question, the shortest question we'll do and wrap it up. Everybody? Everybody, I'm closing this. Topic 1, part 3. Just one question if you can do, something short even. Okay, question number 1, we'll do that. We haven't done it, right? We haven't done a single question here. Question 1. A school purchases 30 desktop PCs for its network. The PCs come with system software but no application software. What is the purpose of system software? That is utility. Shall I say it manages the whole computer system? System software manages your entire computer system, isn't it? So in order to do this, it has utilities and operating system and drivers and language translators, but it basically manages the whole computer system. It is responsible for managing an entire computer system. An entire computer system. Right. State the purpose of application. Services. There's one word, if it will change everything. So you want to do calculations, you will go for an application called Excel maybe, for spreadsheet software. You want to edit a video, you'll go for video editing software. You want to browse the internet, you'll go for web browsing software. So, yeah, so what do they do? Performing what tasks? Allows the user perform specific tasks. Exactly. Helps the user in performing specific tasks. You want to do calculations, you go for spreadsheets. You want to edit a video, you go for video editing software. Helps the user in performing specific tasks. Are we all okay with this?